Okay, we're just we pretty much got this part of it done, but if I was to ask you a question, something like on the API 1104 WPS form, the items that are listed on the left-hand side there, where would you find information about how to fill that in? Where do we find the information or the details about what to put on that line? For example, shielding flux or speed of travel. Where would you look to find out where to put that data?
Wouldn't there be like a process code?
No. Okay. I'm gonna try to repress this again on you. Every line that has something listed here, process material, pipe outside diameter, joint design, filler metal, all of these listed here are also found in the document beginning right here, 5.3. So any of the data, any explanation of what is wanted there will be found in that code book beginning at 5.3. And I must have not made the point, but if you notice, under 5.3, process is the first thing listed. And if you look on the WPS, process is the first thing listed. So if we go down, the next one is material. If you go down to the next thing listed, notice it's materials. Every item on those lines has a corresponding detailed paragraph in the code that explains what is needed on that line. Now, what Drake said is also true. You might have, I think it was Drake said that, you might also have to go outside of that. For example, where it talks about filler metal and number of beads right here. You might have to go, there might be a corresponding specification. Well, let's look at diameters and wall thicknesses. So you have this item on the WPS, pipe diameter outside and wall thickness. It's listed right there on the WPS. So what do we put there? You go down to this right here, 5.3, 0.2.3. So everything's under 5.3. And they'll list a couple of other charts or other details that you might have to refer to. Okay, because I don't know, maybe some other schools require it, but I don't think anybody requires you to memorize the grouping chart for welding rod. After a while, you just know it. You know, group 1, group 2, group 3, group 4. You know those things without having to look. But it's a wise thing to check to see what it says here, and you're going to have an assignment before the week is out that you're going to take one of these blank WPSs and you're going to fill it out. You're going to do a make-believe welding procedure, and you can get as crazy as you want. I don't really care. Just be easy on yourselves, okay? Because if you wanted to weld, 5 chrome to 314 stainless, just be crazy, and you're going to write a welding procedure for that. Just knock yourselves out. But you're going to have, the more exotic you get, the more you're going to have to research beyond the document. So be easy on yourselves. We're limited to API, so that's a smaller grouping of everything. But you're gonna take one of these and fill them out. And I want to make sure before I turn you loose on that you understand that everything that you see listed here, there is a corresponding paragraph or a corresponding section item, clause item under 5.3 that gives you an idea of what has to go on that line. Okay. I'm trying to go down this line by line because, 4 years now I've taught this class. As soon as I turn people loose, I have people coming back to me all the time. I don't understand what I'm supposed to put down here for plasma. Well, did you look in the corresponding data to see what it said there?
So where do we find the data?
You'll have to look. Some of it is what you pick out. So that's a good point. Let's look at this really quick. We're going to do SMAW welding of X52 API 5L X52 pipe. Where did I get that? Where I got that is in all of the API materials. You're going to find them right here under the API 5L pipe. So you might have to Google that.
Code for it.
Mm-hmm. Yep. But I think I went over all that, but it also shows here in this 5.4.2.2, which deals with the smice of the group. So if you go down to 5.4.2.2, right there, base materials, you have 3 groupings: less than X42, 42 to 65, and greater than 65. So what are those grades? So you might have to Google that. But you could pick one of those that are listed there. You could say, I'm going to do SMAW welding of X42 pipe. Right? What are you going to use? Well, I'm going to use 60-10 in the root or 70-10 in the root, and I'm going to use 80-10 on the fill-in cap. So those would be items that you would put here. Pipe, outside diameter, and wall thickness. You choose your pipe size, and how do we determine pipe sizes? We talked about that a little bit.
Below 12 inches.
ID. Over 12 is outside. Okay. Wall thicknesses. Where do you find the wall thicknesses? Might have to Google that. Okay. All you have to do is Google pipe schedule or pipe wall thicknesses, and then you have to look for the API 5L group, and it'll tell you the wall thicknesses that pipe comes in. Is that limited to just that? No. There are a lot of engineered, specified wall thicknesses. The diameters don't change. They're all standard wall, all standard diameter sizes. But if it's less than 12, it's going to be ID. If it's over 12, it's going to be OD. So you might want to do something like a 6-inch Schedule 40 X42. So that gives you the pipe size, that gives you the wall thickness, that gives you the grade. So now you've got that information that you can put in for right here. The material is going to be API 5L X42. CS, you can abbreviate carbon steel as CS, or if you're going to do get a little bit crazy and say you're going to use something that has 1 1/4% chrome in it, then it's going to have a different designation to it. But the reason we're sticking with API is because it's so much simpler. It's regular old carbon steel. So you can put carbon steel, or you can abbreviate it as CS, capital C, capital S. The joint design, once again, you're going to find that right here. Shall include a sketch or sketches of the joint. Notice that there is a standard sketch right there. And if you don't deviate from that sketch, you can just say as illustrated, because this is a standard V bevel butt groove. The thing you have to fill in here is, what is this angle? And that's going to be half. The angle is going to be something like 30 to 35 degrees, plus or minus whatever you add to that. The included angle is both of those added together, but they're not showing the included angle there, they're just showing one bevel angle. The distance of overlap that you're allowed, the distance of excess reinforcement that you're allowed, the depth of the land, and the opening of the root. Thickness of the material is going to be over here, so you're going to have to put that there. So you have to fill in a little bit about this, but if you just use this standard B bevel, it's going to make it a lot easier. If you want to get crazy and do a J bevel or a double bevel, then you could. And then the sequence of beads is for this chart right here. So we've got the diameter and the wall thickness, we've got the joint design, filler metal and number of beads. That's what you're going to have to fill in there. For the root, you're going to be using, and you have to go down to the chart, which I believe is 2-1, right here, table 1. The grouping, if you recall from the code, can you use a group 2 electrode if you've listed a group 1 electrode in the procedure? No, because the code does not allow you to go from group to group. Okay, so you're out on the job somewhere. This has happened to me a lot of times. You're on the job and the procedure calls out for the use of 60-10 in the root and 80-10 for the fill and cap. And the welders will want to use a rod called P1. P1 is 70-10. They like it because it's a lot smoother, a lot easier to run. It has some porosity problems with it, especially if the wind is blowing. But can you let them switch from 80-10 to 70-10 without having to rewrite the procedure? No, because you can't jump groups to groups. Now, can they go from 6, if they want to use 70-10 in the root instead of 60-10, can you do that? Yeah, you can do that because it's still the same group. So you have all of these available to you in group 1. And people kind of laugh that 6011 is in there, but anybody dealt with 6011? Yeah, it's wonderful stuff. It's great stuff. What's the beauty of a 6011? There's DC versions of it. Okay. Yeah. But they built all these machines, these welding machines, back in the 40s, and sold them to all people all across the country. And then they were building ships with AC transformer machines. AC machines, and they were using 60-10 to do the welding, and the ships were breaking in half and sinking to the bottom of the Panama Canal and things like that. And they realized that they were using an electrode. Anything that ends in a 0 has to be done on DC. So they were using an electrode that should have been used on DC, and it was sort of an oh my gosh sort of a moment, because now they have all of these welders all across America, and everybody's using 60-10, and the machine's an AC machine. You ever worked with AC? It's terrible to run. It's really hard to keep lit and welding. You have to keep turning the heat up, so the weld becomes inferior. Well, to solve the problem, they just redesigned the electrode. And they put a different coating on the electrode, and they changed the steel a little bit, and they called it 6011. And they sold it to all these farmers all across the country. So people call it farmer rod. That's where they get the farmer rod. But that 6011 allows you to use it in AC. But the crazy thing about the 6011 now, you can get a DC version because they found out the electrode was much stronger, especially in the case in the not as welded form. But if you make a pass with 6011, then you put another pass over the top of it, it anneals the first pass, and the tensile strength goes to about 85,000. So it's that's why it's still in there. It's okay to use it, but you'll hear that all the time. We don't use farmer rod, we're pipeliners. But that's why it's there. But you could use either of these, you could use either of these. Notice there's a difference in the specification though. So if you go back to the procedure, and you see your specification on the procedure is 5.1, can you switch to a 7010? No, because you have a different specification. That's an AWS specification that spells out the quality and the manufacturing processes that they make those with. 5.5 is a higher level. So 5.1 is a lower level of quality, and it gives us a different kind of a rod. So if the procedure says anything in group 1, you can use any of these. If your procedure says group 1, 5.1, you're stuck with those two. So a lot of times people will write a procedure that says group 1, 5.1, comma, 5.5. If you do that, then you can have any one of those, right? And that should be a welding engineer's call. But quite often it's given to the PE of the job. And he's going to come back to you and go, what do you think? And you're going to say, well, I think you got to put 5.1 or 5.5. Unless you really want to narrow it down so it can only be done with that. Yes?
So if 5.5 is like a higher grade than 5.1, where does something like 5.17 or 5.18 or 5.28 come in?
Those are TIG rods.
Big rods?
Yeah, so it's just a different specification. It doesn't necessarily mean that as the number goes up, they get more critical. It just means in that one category, 5.5, 5.1 and 5.5. 5.5 is a more stringent moisture reduction component to it. That's a good question. So just because these numbers go up in the specification doesn't mean they get more stricter. It just means it's a different thing. These are all stick electrodes, 5.5 and 5.1. And see here it says 5.1 and 5.5 for these. There's actually a couple of different categories for 7018 when you get into the D18 part of it. But when you get to this part here, this is all, 517 is all SAW. This is all subarc. These are the fluxes, and these are the electrodes. And there's actually another specification right here. Any combination of flux and electrode in group 4 may be used to qualify a procedure. Any combination. Okay. These fluxes have different abilities. Some of them just shield the weld. Some of them shield the weld and add metal. Some of them shield the weld, add the metal, and they have a different kind of a cleaning action to it. I mean, there's several different things. And so you have to pick one of these out and then pick one of these wires out, and you will find all of those specifications in that AWS specification. Okay. These are TIG rods, right here, 518, 528. These are all TIG rods, right? This right here is an oxy-fuel. These RGs are oxy-fuel rods. And these are flux cord. These are all flux cord and MIG rods. Right? So you have to make sure that when you're filling out your WPS that when you choose a group for what you're going to be welding with, you also have to put the specification that you're listing it as, and then also the electrode that you're calling out. So for the purposes of filling out the data for these, you should be able to find the description of what goes in each one of these lines. You might have to go outside of the code to find more information. Like none of those AWS specifications are included in the code. They're only listed. So you can go to, you can Google, or you can buy, or you can find them online somewhere. The AWS A5.1 specification, you can find it. It's a fairly long little document. I think it's about 70 pages long. But you will find more engineering data in that other specification. So do you feel like you could fill one of these out? At least that big long section of descriptors, where you have plasma gas flow rate. If you're doing plasma arc welding, or you're using plasma in some form, you would be able to put the rate right there, the flow rate right there. What are you going to do if there is a descriptor here that is not involved in the process that you're using? You're just going to leave it blank? NA. You want to not leave something blank. Why would you not want to leave something blank? Yeah, and you want to make sure that, and that there's not a blank there that somebody else can put something in. Yeah. So you want to put a line through it, or X's, or NA, or none. You want to put something on that line so that your intentions would not be misinterpreted. Down at the bottom here now, there's a little bit more that has to be signed off. And this is for the date. So you're tested on what date, and then the welder's name will go there. And I think I've told you, the welder's name should be a first and last name. Try not to use nicknames. Try not to use pet names, or, you know, CB handles, things like that. You gotta have their first and last name, or at least their initials in their last name. And then how do we mark them down for a 4-digit identification code?
Their month and day.
Month and day. Yes, month and day. So I'm January 7th, so my marker would be 0107. You have to have 2 digits for the month, 2 digits for the date, yes.
What would you do hypothetically if two people had the same birthday and they were working on a project together?
You'd have to put something like an A or a B. We used to do, and we got away from it, we used to do the last 4 of the social. But I guess somehow...
I don't feel like that's safe anymore.
Huh?
I don't feel like that's very safe.
No, it's not. I mean, it's like, we destroyed a lot of records because they have the last 4 of their social. You have to go in and you have to blank it out so it can't be seen. A lot of them are electronic. But somehow, I guess you can use their name in the last 4, and you can get the rest of the Social Security, and then you can open up bank accounts and everything else. So they've gone to using month and day. I have not hesitated to put down, if somebody has a special number, you know, a 4-digit number, you know, 0999, I'll put that down for them. That's what they want. But you have to have some kind of 4-digit identifier for them. And why do we say that we have to have that 4-digit?
So that there's no preferential
Yeah,
treatment?
yeah, because, and they're still out there. These guys are still out there.
Yeah.
I know Drake Nelson, and he's a no welding SOB, and there's no way. I don't care whether he's got this welding qualification record. I know him, and he's not coming on this line. Well, if they don't know his name and they only know him by a 4-digit number, that cuts that subjectivity out of it. So,
At least once.
huh?
At least once.
At least once. Yeah, he'll see him on the line somewhere, and he's like, oh, how did he get here? He's there. Can't get rid of him. I mean, he'll ride Drake's ass for the next week or so. They'll either punch it out at the saloon at night, or they'll become best buddies or something. That's why. Okay, so the welder's name and his 4-digit designation code, and then the approval is going to be done by whoever is doing the testing. So you would be the welding inspector in that case. what I want you to do when we're filling these out is you fill these out and you designate somebody else in this class to be your inspector that's going to look at your WPS and sign off on it. So that way you can look at each other and you can look at each other's WPSs and make sure these come back really correct. So you're going to sign off where it says approved. You could be the welder, I guess, and the approved person, or you could make up a welder name. And then the welding supervisor is going to be the person who is going to check your work, all right? And very, very rarely does the chief engineer or an engineer ever sign a WPS. I mean, you'll see them. I've got some examples to show you, but all of Kern Rivers are signed off by Scott Miles. Scott Miles is their chief engineer, and he knows very, very little about, he's learning, he's getting better, but he knows very, very little about welding. But he signs off on every one of those welding procedures because it actually becomes a legal document. It could be used in court. It can be used in liability courts, things like that.
I don't understand why you sign something that you don't understand.
Happens all the time.
Oh.
Crap runs uphill, but it usually ends up stopping with the inspector. They usually run the other way.
I think just circle back to where it started.
Well, I've been in that position a couple times. I've had to make the statement, you know. Well, I'm more than willing to take the responsibility for this. There's $75,000 worth of welding out there that's been done, and it's been done right. But it's not been done according to your procedure because, and I'm willing to take responsibility for this, because the guy right under Warren Buffett is chewing me out on the phone, and I'm saying I'm more than willing to take responsibility for this. I said, if Scott Miles, if the chief engineer is in the room, are you there, Scott? Yes, I'm here. I'm more than willing to take responsibility for this. If you have forgotten the conversation we had on the right-of-way 2 years ago when I told you this is a bad procedure and I told you to get it out of your code book. Do you remember that conversation? Yes, I do. I said, and you didn't take it out of your code book, did you? No, we didn't. I said, okay, I'm willing to take responsibility since you're willing to admit that. But I'm also willing to take responsibility if George Matus, are you in the room? Yes, I'm here. I said, I told you I needed to be on this job a week prior to the work starting so that I could make sure that all the documentation is done right. And you told me you didn't need me up there until Tuesday, which is 4 days after the welding started. You told me to do that, right? And so I followed through. I didn't show up till Tuesday. Now I'm telling you the welding is not done to the procedure. Well, yeah, but we don't need you up there until they're doing any welding. How do you feel about that decision now? There's $75,000 worth of welding has to be cut out because it's not done to your procedure. Your procedure is wrong, and the welding was done correctly, but it wasn't done to the procedure that I told you to get out of your book, and I would have caught that had you brought me up there last week. So, Mr. Checkets, I'm more than willing to take responsibility for all of this. If those two guys are willing to take responsibility for what they failed to do. And there was a long silence, and it's like, well, that's why we have you out there, I guess. Yeah. But you've got to listen to me. You've got to be able to listen to me. So, anyway, that's a long anecdote, but that's what happens, Steve. That's what happens. Okay, so this is the coupon test report. Once you've filled out that WPS and you had it approved by your supervisor, your co-inspector that's going to sign off on it, then you're going to turn those into me. I'm going to check them over, and if they're done correctly, then you're going to go weld that. You're going to go make a weld. And then when you make the weld, you're going to have to do some test coupons. And when you do the testing, the destructive testing, this is the form that we use. This is also known as the PQR. This is a 1104 PQR. This is the coupon test report. Same thing. Okay. Notice it has the date and it has the location where the testing was being done, and I think for most everybody it's going to be Weber State University unless you do your testing out at Peterson's. Wherever the testing is done, that's the location. State who the welder was, how much time the welding took. There are some companies that say there is a 2-hour limit on this test. If this test takes more than 2 hours, then it's a failed test. Some of the tests that they've come up with for this can easily take you 2 days nonstop. The old Chevron test that was given in Wyoming for the longest time was a 20 on 20 half-inch wall butt weld, followed by a 20 on 20 half-inch wall branch test. And it was an endurance test. You couldn't go home, you couldn't like take a 3-hour break. You couldn't go do anything. You had to start that test and you had to finish that test. And it usually took you all day through the night and up to about noon the next day to get done. They wanted to see if you were capable physically of doing that work and continuing the work in a good quality manner over that long period of time. It was an endurance test as well. So there's always a time element to it. You don't have to follow anybody else's time, but you know, there are guys that can get this test done in an hour and a half, and there's guys that will take all day. They'll take 8 hours to get it done. Okay, so you put down the time that they spent so that whoever is looking at this welder report can say, this guy's really fast, this guy's really slow, we only need one welder, let's take the fast guy. That's why it's a critical part of that. The mean temperature, the weather conditions, voltage, once again that's going to have to be a range. Welding machine type, might be an SA200. Oh, yes, Nathan.
I don't think you have this specific sheet in the packet here.
Yeah.
Really? Okay, I will get that to you. I thought it was in the packet.
It goes right to the blank sample WPS form, GTAW, SMAW, a WPS.
Oh yeah, that's a different one. That's D11, D18. That's a different one.
It just goes right to this, and there's like 3 or 4 copies of this one.
Really? Well, I screwed up there. I'll make sure you get one before you need it. Take a picture of it or something for now, or just hang tight, and I'll get you some copies. About out of time. We're going to cover this. So all of this pertinent data for how the testing was done. Notice there's some things on there that you're going to need to write down before the testing starts. You know, you can't do the WPS and then do the testing and then come back and fill some of this out, because some of it's going to be like the day before. So you've got to be right on top of it with this. I was just training a QA guy for a senior project, and he thought all they had to do is just be there when they were doing the test, but they had to do, there's a lot of things that you have to keep track of while they're doing this so that the test can be a good test of what this welder has done. A lot of this stuff has to be put in here at the same time that you're beginning the test. The time of day, the mark, the top column, that's where that 4-digit number goes. You don't put the guy's name, you put the welder's over here, but his mark is over here. You have to make sure that you put your mark. And his mark. And let's see what else is there. You got voltage, amperage, welding machine type, welding machine size, the filler metal, if there's any reinforcement. What are you going to do if it's open root? Yeah. Is there going to be any kind of a backer bar or anything like that, open root? All right.
No.
Reinforcement size is going to be determined by the sketch that you have on this page. Reinforcement here and reinforcement here. Okay. So, I thought I saw it back in, I guess not. So reinforcement size is gonna deal with, excess reinforcement or concavity, whether, how big was the reinforcement? And if you have on this drawing right here, that it's supposed to be 1/32 to 1/16 of an inch, that, it better be less than that. Reinforcement better be less than that. So this drawing is gonna determine the data that you're gonna put there. If the reinforcement size is 3/32 of an inch, did he pass the test? That's a visual flaw that he's made the weld too big. There's too much reinforcement. Why is too much reinforcement bad?
Stress riser.
Stress riser, yes. Extra stress. Anyway,
But that one's easily fixed.
okay. In this little matrix right here, there are several different tests that can be pulled out of these, depending upon what test you're doing. This is going to be root 1, root 2, face 1, face 2, nick 1, nick 2, maybe a tensile or 2 tensils or whatever is called out. And we're going to look at the chart in a minute. The original specimen dimensions. So when we're doing a tensile test, these dimensions have to be put in to 3 decimal places. So if you have a 0.25 by 0.500, can you determine the area of that? You just multiply one by the other, and then you get this specimen area that goes right here. This will be in square inches. This will be in a decimal inch to 3 decimal places. And then these 2 indications here are going to be, this will be the tensile strength where it broke, but the maximum load is something different. Most tensile testers do not have a range that's going to show you on a gauge that this broke at 46,000. It's going to say that it broke at 7,000. So the load number is going to be the amount that's on the gauge of the tensile tester. And every tensile tester usually has a multiplier that you have to multiply it by. That multiplication number is basically the size of the cylinder. So if you have a 2-inch hydraulic cylinder ram that's doing the tensile testing, what's the square area of a 2-inch ram? Pi times the radius squared. So 1 squared is 1 times pi is 3.14, so you have 3.14 square inches. So you multiply that times the load to get the tensile. If you're lucky enough to have a tensile puller where it reads out in digital or something like that, it'll give you the load and it'll give you the actual tensile. But you can figure out the tensile from the load and the square area. They're functions of each other. Okay. And just real quickly, I'm going to try to get through this. Notice here, you can make a check here whether it's for a procedure or whether it's for a welder. Can you check both of those? Yeah. If you're doing a procedure test, and you got a welder doing that procedure test, and the procedure passes, he's a qualified welder. So you can check both of those. Is it a qualifying test or is it a line test? Is it out on a production line? So you're testing one of his production welds? You can also do that. If he has a previous certificate and it's out of date, you can take him out on the line and you can let him do one weld, and then you're going to take that weld as his test. And if he passes that, then he's a qualified welder again. You just restamp his certificate with a date. But you're gonna put that it was a line test. Okay? A qualifying test is one that's done in the shop, and most everything is a qualifying test. And then whether he's qualified or disqualified. can only check one. And as much as our engineering friend in our article doesn't like it, you can reject him right there. So here's the maximum tensile pull, which you'll get from one of these data points here. The maximum tensile here, the minimum tensile here, and then you add those up and you divide by the number of tensils to get the average tensile. Any remarks you want to put can go here. You know, on the bend test you might put small porosity less than 1/32 of an inch. You can put that on there, or not. If he passes, he passes. But you can put any remarks that you want here. The test was made by, or test was made at, this is the location where it was made, company. Tested by, that would be you, the date, and then your supervisor is going to sign off on it here after he checks your data. So, you should be able to fill one of these out for the most part. And then I'm going to have to get you these, but you should be able to fill one of these out as well now that we've looked at these procedures. What I want you to do, I think you have a copy of this. Or if you don't have a copy, come see me and I'll make you a copy. But, and I would suggest that you take one of these and make it your junk copy, because you're going to cross things out and you're going to write new stuff in as you fill more data in. You're going to fill those in, so make one a junk copy, and once you have it all like you want, then take a clean copy and fill that out and give that to your inspector to check over your work. Okay. You think you can do that by Friday? Or would you rather have the weekend for it?
Just the paper?
Just the WPS, the top part, just the top part.
Yep.
Okay, let's give this a shot. See if you can fill out a WPS. Be easy on yourself. Don't make it too crazy. Fill out the data as best you can. Pick out somebody in the class. Have them sign off on your work. Have them look at it, sign off on it. They might see something that you didn't see, so you can get it corrected. And so both initials on that for Friday, for an assignment for Friday. We'll also have another quiz on Friday. We've covered most everything on there. We've covered most everything on there, but I'll make sure that I don't throw anything in at you that's a cheap shot. Okay? Sorry for holding, I didn't hold you over too long.